r is equal to 6 times 1 minus e to the minus 2t. Okay, and so the easiest way to solve these is just go ahead and take your first and second derivatives. So they do the old-timey thing of r dot is first derivative, r double dot is the second. So this would be minus 6 times minus 2t e to the minus 2t, right? That would be the derivative of that. Right, and then, so this would be equal to 12 e to the minus 2t. Okay, and then your double dot would be equal to minus 24 e to the minus 2t. Okay, so now we have all of those, and we'll do the same thing with this. So your first derivative of theta would be 3 times pi over pi sine of pi times t. Okay, so the pi's just kind of go away. And then your theta double dot would be equal to 3 times pi up. You guys catch my mistake here. That would be cosine of pi times t. Okay, and then the derivative of theta double dot would be my negative 3 pi sine of pi times t. So just calc 1 derivatives here, and it wants us to determine the velocity acceleration when t is equal to 1 second. Okay. So I would just plug 1 in here, so this would be 3 over pi sine of pi. So sine of pi should be 0. And then this would be 3 times the cosine of pi, and that would be negative 3. And then again, sine of pi would be 0. So now you have that in some nice, simple numerical values. And then we would do the same thing over here at t is equal to 1. So this would be 6 times 1 minus e to the minus 2. Okay, and you could get that to be a particular number. This would be equal to 12 e to the minus 2, and this would be minus 24 e to the minus 2. So let me see what that number is, just to make it a little bit shorter. So if I did that right, it is 5.19. This one is 1.62. And this one is negative 3.24. Okay. The units on this would be, what is the units here? So inches and seconds. So that would be inches per second, and inches per second squared. Okay. And the units on here, this is an angular unit, so this would be radians per second, and radians per second squared. Okay. So this is the hard part of it, and then once you do that, you just substitute it into the equations here. So the equation for velocity is, do not have that committed to memory, but it's pretty easy to look up. It is equal to r dot e sub r. So this has to be your r dot, and then times r theta dot. So this is, my R dot is 1.62, and then plus R times theta, so 5.19 times my theta dot, which is -3. And then you just crunch those numbers out. And then once you have to do this acceleration, then it is that little bit longer equation. You would do R double dot minus R theta dot squared. Yep, does that help?
Yeah.
Yeah. So it's a lot easier to just find the derivatives, figure out numerically what they are, and then, plug them into those equations, as opposed to trying to plug in all of the equations into that big long equation. Right. And you'll get a chance to practice that today also. So we have finished up this chapter, and so what